and the data came from the projects. So we have to assure that the project information model can deliver at the end of the project all the information to the asset information model. Altogether, from our point of view, it's a conceptual view forming the common data environment. And let's see what is in a common data environment. Next slide. Yes. Basically, we talk about the same thing, namely our infrastructure assets. So it should be very simple for everybody on that. But depending on the role you have in the lifecycle process, the abstraction of the real world is slightly different. So we have the owner, which for him is important to have the requirement, to have the utilization of his infrastructure. We have the planner and contractor, which are mostly interested in delivering the project in cost and time, and so on. And we have on the other side, in the operation and the maintenance, the asset manager, which wants to have the best asset manager operate the asset management. But for that, if we see, we have these different views, and how can we bring these different views together? Well, we think we need, firstly, we need a common terminology to define our asset system clearly, what we want, and then we need some model for the data, some data model. On the semantic level, we need a data catalog, and on the conceptual data model, we need some conceptual data models to be able to give the requirements to the common data environment where all things are put together. And of course, if we are looking at the exchange requirements we have during the processes, we need some standards. And here is clearly positioned the IFC standard. Okay, next one. So if we look a bit deeper into the CDE, what is the structure of such an object? Of course, we need the defined business objects, which are to be maintained in the BIM. And for each object, we have three main parts which have to be defined. Firstly, we have to define object identification. It's a unique object identification which permits to manage and to retrieve the object over the life cycle. The second thing is also very important. It's the spatial reference of the object, which permits us to position it in the real world. And the third thing is the time, the temporal aspect, so the historization and the prediction of the data and properties of the objects to be able to follow all the life of the object in time. And Mark will present now some details on that.
Thank you, Kirod. You mentioned it, business view first. So we are working with business with objects in the rail system, physical objects. Every one of you knows some of them. So at first there is a catalog with business objects to build and to prepare. They have process-related objects. Some objects are maybe needed only in one phase or of the lifetime, and this objects carrying the information about the specification and whatever. The objects has to be unique and with an international description. So that's the base that an exchange will work, especially that all these containers can be exchanged between the systems and the errors. Some of the properties for identification to guarantee the uniqueness about an object. Then it's a set of properties for all the different processes which this object will be needed in. And as well standardized for a proper data exchange. So for example, IFC Rail as this data exchange format. From IFC Rail, you find this catalog of all the railway object type catalog with the models and the descriptions. they are available. So the first step is done to work with the business objects. Next one, Tamo. The second one, what was Claude mentioned, is this unique object identification. You all have IDs and know some of this identification. I just want to say it's not only a local BIM model where, as we have seen in the beginning, turnout panel has an identification. No, this turnout panel is unique in the whole network. You can have it on the left side in an area, in a region of Zurich or in Switzerland, somewhere in the network. This panel must be unique. It must be has a unique identification, and at the bottom of the slide you see, and during the whole lifetime of the object, this identification must be stable. So from the start to the end. Yep. That's already Claude's slide. Thank you.
Thank you, Mark. So we are switching to the localization and the positioning of the objects. Yeah. Oh, slide. A bit better with the slide. Yeah, thank you. Okay. Yeah, we well know for the positioning that we use currently geographical coordinates for positioning our buildings and so on. We have also the local positioning system inside the projects we use. But what is special for linear infrastructure is that we need something called a linear referencing system. A linear referencing system is something which helps us to position an object along a curve. And that is something we have. This is one special additional things in IFC 4.3, which was extensively tested also last year, and this will be a major extension of the IFC standard for that, which will help us in the infrastructure BIM to go forward very fast. Yeah, next slide, please. Here's just an example what is meant with a linear referencing system. We have our, for railway, we have our alignment with Kant, which is defined with three curves. We have a horizontal alignment, a vertical alignment, and a Kant alignment. And these three curves together are combined to give us the linear referencing system, on which we then can position the turnout panel. And this is the panel is positioned linearly on the alignment. That's one thing. And then the second thing is that we have some objects which are linearly positioned inside the panel, so that we need also a referencing system inside the turnout panel. That means that this example shows the requirement of nested linear referencing systems, which are currently available in IFC 4.3. Next one. Now the historization we talked about. Yeah. For that, we need, as a requirement, we need to record every change happening on the turnout panel during his life cycle. So we have the first changes which are during the construction phase, from the planning to the commissioning, which are recorded the time aspects, and then we have during the operation phase all the activities like tamping, grinding blade, and replacing a frog, which either make a change in an attribute or also create a new object for that. And all these events have to be stored only with time attributes in the common data environment. Next one. Yeah. So now have a look in the visualization model Mark introduced at the beginning. If we set up these requirements for the location, the time, and the uniqueness, we should be able to generate the visualization model as a screenshot from outside the TDE using a filter. And the filter means that we can select the type of objects needed in a specific perimeter and for a point in time. And in combination with graphical parameters for visualization, we should then be able to generate a snapshot for different BIM models, like existing condition model or as built model and so on. So really what is important is that we have all the data in the CDE for that, in the structure we mentioned before. Next one. What is the impact on the application of BIM methodology? What we want to do is we have to ensure the sustainability in the future, right? So looking at the structure, we need this CDE with standardized structures, and the CDE will form the basis for the data exchange across all processes, and so we can avoid media breaks, right? What is also important is that we have in the structure we use for the data exchange, we use open and product independent interfaces for the data exchange based on IFC, of course. For the identification of the objects, we have to ensure the uniqueness of the IDs, because we have in linear infrastructure, we have large infrastructure networks, right? And so for that we need to define some identification conventions. On the process side, we need to ensure the mastering of the IDs for the exchange between different systems, because we have a lot of spread data sets for that. The spatial reference, we need a distinct integration into global referencing systems. I heard in other sessions that GIS and BIM are very important, and that's exactly for that, that we need this integration with the spatial reference. And we have the standardized location of objects in the linear referencing systems, which are given now with the alignment concept, which was added in IFC. For the time reference, we need, of course, also to manage the updates of all the information over all the processes. For that, we need clearly defined roles and responsibilities for that. And on the structure side, we need this time reference mentioned before in the objects, which are used either as an information or also as a selection criteria or filter for the visualization. Yes, next one.
Thank
Mark?
you, Claude. You bring us already to the conclusions. Well, there are some really big challenges for the infrastructure company ahead. Today, we are in the middle of a change process. This way forward, it leads from small perimeters to large networks, from limited data sets to mass data, from a planner view to a linear approach, from high levels of details to simplified abstractions to avoid mass data, to make the performance, to keep the performance of the systems and so on, from project planning and construction to lifetime operation, from months to decades for continuously data management, and from graphical objects to intelligent, clever data objects. That's the challenge in the future. And the next slide gives us some, we would like to give you some giveaways. Please keep in mind, now the first row, keep in mind, a BIM model is not 3D, but it's much more boring. Next one. BIM in projects is only the birth phase. The long life follows afterwards. Next one. A standard now fits to everyone, but only due to it, everything fits together. Next one. BIM models are already out of date after they have been designed, unless they are systematically updated. And the last one. So, what is the digital twin now? It's the source. The source of all information is in the CDE. Next one. So, if we are able to model and describe this station entrance of the Zurich main station, then we really are on our goal. Many thanks for your attention. We will looking forward to see you then next time in Tampere again live, all together. Thank you. We are here now for question and
Merci beaucoup. Merci.
Thank you, Mark. Thank you, Mark, and thank you, Claude. Now it's time for a few questions. Any questions from the audience? Karin, do you have any questions from chat?
Yes. The chat, no, there are no questions. But we do have some questions, Tarmo, that you very well prepared for us. So I'd just like to say thank you, Mark and Guy, for this presentation. It was very, very informative, and I'm glad to see that you are on the way to succeed in the big challenge of getting everyone on board with working with digital twins and BIM in infrastructure. I would just want to say to you, Mark, that 3D makes it not so boring, so we need to make cool 3D models to get all the project participants involved. Just one question that both Tarmo and I are very interested in is how do you have any tricks of getting busy project managers to see these data models as being just as important as the actual physical infrastructure when you're done? Do you have any thoughts on this?
Well, I think that one of the goals is that the people understand what is happening, what is behind, that it's not just the thing what they see, that there are logic things behind, that they have to start maybe early in the project phase with properties and with work. They not see the purpose for the moment, but they have to accept that with generating some information, the life start of an object. Claude?
Yeah, I think what is also important is to tell them that in the future, the contractors will not only want to get the system and the assets, but also the data. They are ordering also the data, and it's a part. It will be a part. Structured data will be a part of the deliverables, a mandatory part of the deliverables. But this will take time. It's take time. You know, we are just also in Switzerland. We are just starting the process. Huh? We're just starting the process. I think in the Nordics you are far more forward than us. Maybe, I don't know. But it will take time, and we try also at SBB in the pilot projects and so on to make the importance of the data to show them that it's essential for the future. But it takes time. So we have no what do we say, magic answer on that.
Thank you.
People management.
And audience,
Yes.
any questions?
Are we finished? We have no more time, Tarmo?
Yeah, I think we say thank you for Mark and Claude. Thank you very much for your presentation.
Merci beaucoup.
Thank you.
Merci.
Thank you. See you. Bye-bye.
Bye-bye.
Okay, thank you. And the next presentation will be here in live. It's a development of an integrated OpenBIM IoT DL-based approach for the SHM of infrastructure, case of the Grand Paris Express Tunnel. Mr. Noor Eddin Al Haddadi, welcome.
Welcome.
Just a second. Little technical break. Presentation is ready here. Okay, now you can start.
So we can start in French, no problem. Okay. Bonjour à tous. Donc j'ai choisi de faire la présentation en français, mais vous pouvez me poser des questions effectivement comme vous voulez, en anglais ou voilà, en français. Donc les slides sont en anglais, donc vous pouvez suivre avec moi pour des gens qui nous suivent à distance. Donc voilà, donc ce que je vais vous présenter aujourd'hui, donc c'est un digital twin, c'est un cas de jumeau numérique qu'on a développé chez Secotec Monitoring pour l'activité d'auscultation. D'accord, donc c'est juste pour savoir que donc avant on était Semontis et à partir de 2022 donc on est devenu Secotec Monitoring, c'est juste pour voilà, pour information. Donc là le jumeau numérique, donc on a intégré effectivement donc le BIM avec l'IoT appliqué à l'auscultation, donc tout le système d'auscultation basé capteur. Voilà, avec bien sûr une composante de prédiction basée sur le deep learning, bien sûr afin de suivre voilà, les ouvrages d'une façon voilà, la plus efficiente et efficace possible pour nos clients. Donc je vais essayer de vous présenter notre démarche dans ce cas de figure, sachant que on a déjà des projets donc, réels, donc on a appliqué ça sur le Grand Paris et après donc, sur la tour de Mélange avec Hoffmann-Sémontrie. Donc c'est deux cas de figure qui sont réels et on a vraiment senti donc, voilà, les fruits de cette démarche donc, de jumeau numérique. Donc, je pense que tout le monde maintenant, il est convaincu voilà, de l'apport d'auscultation et de monitoring parce que voilà, donc, il y a des infrastructures et des ouvrages d'art qui vieillissent et parfois ils vieillissent mal. D'accord. Et les maîtres d'ouvrage aujourd'hui s'inquiètent pour effectivement donc, prolonger la durée de vie voilà, de certaines infrastructures et ils recourent parfois effectivement à des systèmes d'auscultation et de monitoring automatique afin de voir effectivement donc, les données derrière, comment ça évolue et suivre les différents paramètres. Donc ça c'est... Donc je ne vais pas vous rappeler les drames qui ont eu lieu, donc ça peut arriver dans n'importe quel pays et pour n'importe quelle infrastructure. Donc c'est arrivé par exemple en Italie à 2 reprises pour les drames. Et voilà, donc c'était le cas aussi en France et ailleurs à travers le monde. Donc il y a toujours des cas pareils qui sont dus parfois donc, à un manque de suivi donc, de l'infrastructure comme il faut. Aussi, pour des projets en chantier, voilà, je cite le projet du siècle donc, de Grand Paris Express. Donc là où, effectivement, donc, le maître d'ouvrage a exigé donc, de suivre le projet en lui-même et ses avoisinants, donc, du moment que ça présente effectivement donc, des exigences et des impacts qui sont énormes sur les infrastructures avoisinantes. Donc aujourd'hui, Secotec Monitoring, donc, il est sur 40%, voire plus, bien sûr, avec le nouveau marché donc, de la 16.3. Donc on est sur la ligne 14, on est sur la ligne 15 sur 2 lots, on est sur la ligne 16 sur les 3 lots, etc. Donc, et on suit bien sûr prochainement donc, les autres projets. Donc en fait, la particularité voilà, de ce genre de projets qui sont énormes d'autres envergure, c'est qu'on est face parfois donc, à plusieurs variables qu'il faut suivre et monitorer. On suit l'inclinaison, on suit le tassement, on suit la contrainte, la déformation dans des ouvrages souterrains, à la surface, etc. Donc beaucoup de paramètres qu'il faut suivre à la fois. Et on est sur des structures différentes, sur des parois moulées, on est sur des tunnels, voilà, donc de la convergence parfois. Et du coup, donc, les maîtres d'ouvrage demandent parfois donc, des niveaux de précision qui sont assez élevés et il faut bien sûr alerter lorsqu'il y a un problème. Donc tout cela voilà, nous pousse effectivement à choisir une démarche donc, de suivi, un système SHM donc, de monitoring qui est fiable, précis, voilà, et qui permet d'agir au bon moment et d'anticiper certains dégâts. Donc du coup, nous, ce qu'on a proposé sur la ligne 14, donc sur des sites pilotes avec Razelbeck, donc de développer sur des sites pilotes, effectivement, donc un système basé BIM, c'est un jumeau numérique, voilà, qui intègre à la fois donc des données d'auscultation avec des modèles BIM. Donc c'est du moment que en fait, les projets sont déjà en BIM et on a essayé bien sûr de les enrichir avec notre système sensoriel SHM. Donc, les objectifs spécifiques donc, derrière donc, cette approche, donc d'abord, il faut qu'on mette en place une base de données structurée. Donc, de ces données, il ne faut pas voilà, faire envoyer dans tous les sens à gauche et à droite, mais plutôt, il faut que ce soit une base de données structurée qui va prendre en charge toute une quantité. Et bon, c'est une problématique d'ingestion. Et voilà, vous l'aurez compris, que c'est une base de données qui est chronologique, dynamique et n'est pas statique. Deuxièmement, donc, sur la base de ces time series, donc on a fait face à des problématiques, c'est parfois les week-ends, donc c'est des systèmes qui fonctionnent en temps réel. Et du coup, on n'a pas voulu donc, multiplier les astreintes et on s'est dit, est-ce que c'est possible que ce système prédit effectivement donc, le samedi et le dimanche le comportement de ces ouvrages et parfois peut-être prévenir certains manques de données ou des trous, ce qu'on appelle les nonnes. Et du coup, là, on est arrivé effectivement donc, à répondre avec certains niveaux d'exigence donc, à cette question. Troisième partie, donc c'est effectivement, donc on ne va pas venir voilà, intégrer ces capteurs voilà, dans un modèle BIM qui est propre. Il faut que ça soit intégré voilà, dans une démarche Open BIM. Il faut que ça soit, voilà, il répond aux normes de l'EFC, etc. en question. Et du coup, donc, ça nous a demandé un peu plus de développement pour ce système, pour qu'il soit bien sûr conforme aux exigences en question. Et finalement, donc, lorsqu'on est arrivé donc, voilà, à avoir donc, ces trois piliers voilà, de la démarche, on a pensé à une intégration dans une plateforme collaborative où le client et le maître d'ouvrage pourraient bien sûr effectivement donc, faire les opérations et suivre leur projet comme il faut. Donc du coup, là, on a fait un appel à une notion, ce qu'on appelle le Monitoring Information Modeling. Donc c'est au lieu de, donc c'est du BIM, Building Information Modeling, mais puisque donc on l'a appliqué effectivement au monitoring, donc ça c'est un terme effectivement qui existe dans la littérature. Donc c'est le système SHM de monitoring. Voilà, qui est augmenté par voilà, le modèle BIM. Donc, c'est ce qu'on appelle le MIM, Monitoring Information Modeling. Donc, en quoi consiste effectivement donc, cette démarche? Donc, d'abord, on part d'un modèle voilà, BIM du projet, d'accord, qu'on peut développer chez nous ou bien donc, mis à disposition par notre client. Et après, effectivement, donc, on développe donc, le modèle BIM de notre système sensoriel. Les capteurs sont divers et variés et du coup, donc on essaye quand même de développer donc, cette stratégie BIM pour ces derniers, bien sûr en fonction de, voilà, des exigences en vigueur. Ça peut être de l'open BIM comme ça peut être de le close BIM. Et après, voilà, donc c'est la particularité de ces capteurs, c'est qu'ils sont dynamiques, ce n'est pas des objets statiques. Donc, du coup, il faut qu'on mette en place donc, une infrastructure de base, c'est une base de données qui va accueillir donc, ces données en question. Et au final, donc, voilà, data visualisation et traitement. Donc, c'est-à-dire que dans un environnement BIM où toutes les opérations de traitement vont se faire. Voilà. Donc, l'objectif du BIM, effectivement, à travers cela, c'est qu'il ne facilite, c'est-à-dire que s'il y a un problème au niveau d'une structure en question, on pourra facilement l'identifier et la repérer. Est-ce qu'il s'agit, par exemple, d'une corde de convergence à l'intérieur d'un tunnel? Est-ce qu'il s'agit, par exemple, je dirais n'importe quoi, donc une tête de paroi moulée qui s'incline ou qui se tasse, etc. Donc là, tous ces éléments-là, donc voilà, avec un modèle de jumeau numérique, on pourrait facilement le déceler. Et du coup, donc s'il y a une alerte en question, donc on pourra facilement la visualiser. S'il y a des interventions à faire, on ne va pas chercher dans les bases de données où vous imaginez bien sûr tout le listing et on pourrait bien sûr tomber sur la mauvaise information. Donc tous ces éléments-là, effectivement, justifient voilà, l'intégration voilà, du BIM dans notre système voilà, d'auscultation et de monitoring. Alors, donc ce qu'on a ce qu'on a remarqué lorsqu'on a commencé effectivement donc ce travail, c'est que le standard IFC n'a pas intégré donc ce genre de capteur. Certes, donc il a intégré des capteurs dans le bâtiment, genre un capteur de température, etc., mais des capteurs de monitoring, voilà, avec toute la liste exhaustive. Donc on a trouvé que les énumérations sont très limitées. Donc ils sont très limités et du coup on a essayé quand même de se poser la question. Comment on pourra faire? Est-ce qu'on va documenter donc, le standard en question ou on va essayer de faire bien sûr des exports donc, de propriété? Donc du coup là c'est une question ouverte qu'on pourra bien sûr discuter avec Building Smart International. Yeah. Yeah. So, donc les capteurs normalement, donc, comme j'ai dit, donc, on a préparé une base de données. We prepared the database. It's a chronological database that receives the time series from physical sensor, and then this database is connected to the BIM database. And we have a streaming in real time, and we can visualize and Sorry? Yeah, so you have connected the two databases, and then we have a streaming in real time. Yeah, and then we can configure the frequency depending on your need. Okay. So then, bon, je continue en français si vous permettez. Du coup, donc les énumérations, voilà ce qu'on a remarqué à ce niveau-là. Donc c'est qu'on a bien FC Sensor Type et FC Sensor, mais à ce niveau-là, les énumérations qui ont été définies. Donc du coup, on n'a pas les capteurs qu'on cherche, genre un inclinomètre, un extensomètre, un capteur de vibration, un sonomètre, je dirais, voilà. Et du coup, donc, ce qui nous a poussé un petit peu à réfléchir à des méthodes donc, d'export pour que notre capteur figure bien dans le modèle BEM, mais ce n'est pas juste quelque chose, voilà, sinon le maître d'ouvrage va nous dire que c'est un objet qu'on va nettoyer et c'est n'importe quoi. Voilà, donc la méthodologie, voilà pour répondre à votre question, donc elle est assise ainsi, mais bon, je ne vais pas effectivement entrer dans les détails, sinon ça va être un petit peu ennuyeux, mais conceptuellement, donc on a commencé par le BIM pour le projet en question, et le BIM du système sensoriel des capteurs, qu'on a essayé d'étendre, ce qu'on a fait la documentation juste de l'EFC. Et après, voilà, donc les capteurs aussi, donc ils ont une base de données. C'est à ce niveau-là où tous les traitements, où les données sont reçues, où les traitements sur les données brutes effectués. Et après, voilà, il y a une plateforme, effectivement, voilà, donc d'intégration, connexion base à base, qui permettent effectivement donc d'héberger toutes les données, les deux à la fois, et visualiser comme il faut, voilà, les deux systèmes. Voilà, donc du coup, ça c'est juste une information, donc ça c'est un petit morceau donc, de toute la base de données. Donc du coup, la question qui s'est posée, est-ce qu'on va opter pour le système SQL ou non SQL? D'accord, donc vous l'aurez compris, c'est que les deux, bien sûr, ils ont des divergences et des avantages et des inconvénients. Donc nous, on a publié un article dans ce sens parce qu'on a essayé donc de tirer profit, voilà, des deux approches. Donc c'est une base de données qu'on a développée, voilà, hybride, SQL à la fois et non SQL. D'accord, pour qu'on puisse effectivement donc, garder le système tabulaire par table compréhensive et en même temps donc l'approche non SQL qui permet d'héberger les données de l'IoT du moment qu'elles sont massives. Voilà. Voilà. Après, voilà, donc j'avais parlé donc d'une composante donc de prédiction et de forecasting pour le week-end. Donc ça, c'est juste un exemple. Donc du coup, on a fait beaucoup de tests sur les données. Du moment que notre base de données il est assez riche, le projet on le suivait sur 4 ans, d'accord. Donc du coup, on a fait un historique de données, voilà, de 2 ans, qui nous a permis effectivement de prendre en considération les aléas, donc le week-end, plutôt l'effet de saison, l'effet de température, etc. Donc beaucoup de paramètres qui ont effectivement contribué à l'affinement, voilà, de modèle en question. Après, donc, il y a l'OpenBIM pour les capteurs. Donc, du coup, voilà, donc on a commencé, voilà, donc le projet, on avait déjà, c'est C'est une GEROP d'ailleurs qui nous a effectivement, donc c'est eux qui ont dicté voilà, le système sensoriel à mettre en place. Donc on a respecté, etc. dans le cadre du marché. Et après, donc les capteurs, on a essayé donc de les positionner à leur endroit sur le modèle et on les a intégrés. Du moment que tout a été intégré, bien sûr sans perte de vue sur l'extension et la documentation qu'on a faite, sans que ce soit vraiment donc, des énumérations définies, on a fait un export de paramètres de ces capteurs pour qu'ils soient bien sûr intégrés dans l'EFC en question. Et après, donc, lorsqu'on a défini l'infrastructure de base, on pourra passer à l'alimentation. Donc là, c'est juste un exemple. Donc c'est un site pilote de la ligne 14 du Grand Paris Express. Donc c'est la gare C3C. Donc, vous voyez que ce n'est pas un modèle 3D, mais plutôt un BIM. D'accord, on peut l'éclater. C'est un modèle intelligent. Chaque objet il est documenté effectivement. Et après, donc là, c'est 3 capteurs que je pourrais présenter. Par exemple, c'est un prisme, c'est un système topographique. Là, c'est un système de contraintes structurelles et l'autre, il est géotechnique. Par exemple, c'est un capteur inclinomètre. Donc, la liste n'est pas exhaustive. Donc, beaucoup de capteurs, beaucoup de développement qui a été fait et du coup, le capteur a été bien documenté selon les informations dont on aura besoin pour le requêter, l'interroger, etc. Voilà, et la liste, comme j'ai dit, n'est pas exhaustive, donc il y a beaucoup de capteurs dans ce sens. Et tous ces capteurs ont été effectivement pris en charge dans le standard et les exigences du projet. Voilà, donc on a fait des tests effectivement d'export pour voir effectivement est-ce que dans le modèle IFC on va retrouver les capteurs. Donc on a fait juste un export de paramètres, suite à quoi on s'est retrouvé effectivement avec des objets qui ont été bien définis dans notre modèle de sortie. Donc l'intégration au final, donc du coup comme j'ai dit, donc on a la base de données voilà, du BIM. Après, on a l'hybrid database. Donc, pourquoi hybride? Parce qu'il y a à la fois le SQL et le non-SQL. Donc, c'est une base de données qui permet de gérer donc, le temps réel, le fait que la base de données elle est dynamique. Et après, donc voilà la plateforme d'intégration qui a été développée. Donc, il y a un front-end, un back-end et il y a un front-end. Et voilà, c'est au niveau de cette plateforme qu'on pourra effectuer les différentes opérations, la visualisation en temps réel, les graphes pour afficher les capteurs, la prédiction des données, la définition des seuils et l'interprétation, etc. Et on est en train d'interagir avec le modèle. Voilà. Et là, par exemple, c'est des illustrations. Ça, c'est juste des illustrations en phase chantier. C'est-à-dire que là, par exemple, c'est un projet en construction, c'est une boîte de gare, d'accord? Donc, c'est des panneaux de parois moulées où vous avez des capteurs, des chaînes qui sont définis, bien sûr, dans l'EFC et qu'on voit exporter ici. Voilà, c'est un modèle. On clique sur le capteur, on affiche bien sûr ces données et vous voyez qu'il y a toujours une composante en avance de prédiction qu'on a bien sûr validée avec plusieurs tests. D'accord? Donc on clique, s'il y a un dépassement de seuil, donc on a défini les seuils en question, s'il y a un dépassement de seuil, on serait bien alerté. Et ce qu'on a essayé de faire aussi, ce que vous voyez, c'est de la couleur. Donc l'effet de couleur n'est pas juste pour faire beau, mais plutôt ça reflète effectivement donc, la mise à jour d'un élément fini qu'on a récupéré et après ce qu'on a affiné avec les données du capteur. D'accord? Donc le capteur a contribué effectivement à voir, donc c'est un exemple de jumeau numérique. Là, c'est un exemple un peu, voilà, un peu loin, c'est-à-dire en phase exploitation. Donc la gare, elle est finie, etc. On a récupéré le modèle et on a gardé les capteurs, par exemple, des jauges de contraintes qui restent noyés dans le béton. Et du coup, on suit la déformation, etc. Vous voyez, donc on peut interagir avec le modèle, voir le capteur où il est, et le modèle est bien dimensionné. Voilà, donc du coup, les différentes phases qu'on pourrait avoir, les données elles sont affichées directement sur les capteurs. Donc, vous voyez des capteurs ici. Donc, les données sont affichées. Si c'est vert, si c'est il n'y a pas de problème. Si c'est rouge, ça veut dire qu'on a dépassé l'alerte, etc. Et on peut toujours les désactiver, les réactiver. Et c'est des modèles définis dans le standard IFC. C'est-à-dire qu'on ne pourra pas dire que c'est juste nous sommes en train de faire de n'importe quoi sur le modèle. On peut les désactiver, les dissocier. Ce sont des objets bien définis. Voilà, donc du coup, juste pour conclure et ne pas trop tarder, ce qu'on a mis en exergue à travers cette étude, c'est qu'on a développé donc, cette base de données hybride qui nous a permis effectivement donc, d'intégrer les données voilà, des capteurs qui sont massives en temps réel, d'accord? Et comme je vous ai dit, on a publié un document là-dessus. 48 heures donc, de forecasting des données. Donc ça, c'est un modèle qu'on a affiné et qui est toujours, bien sûr, dans notre département de recherche qui est en train, bien sûr, d'être travaillé pour étendre cette durée. Et une intégration voilà, d'un système SHM dans un OpenBIM. Et là, c'est une discussion qu'on va ouvrir peut-être avec Building Smart pour voir effectivement si capteurs est-ce qu'ils ont été intégrés dans la version 4.3, etc. Et voilà, la plateforme qu'on a obtenue, c'est qu'il y a de la clarté, l'efficience et la rapidité de prise de décision parce qu'on voit effectivement le capteur où il est inséré sur le projet, qu'est-ce qui se passe sur ce capteur et est-ce que ça va ou ça ne va pas. Et du coup, aussi, il y a l'interpolation qu'on a faite sur le modèle. Donc, vous voyez l'effet de couleur. Donc là, c'est un modèle complexe qu'on a essayé d'intégrer et que nous sommes toujours en train d'affiner. Voilà. Donc, du coup, c'est ça. Après, les perspectives et les limites, c'est le sujet qu'on vient d'évoquer, les FC tunnels, FC sensors. Est-ce que c'est quelque chose qui est limité ou on pourra bien sûr développer davantage les énumérations? Et cette application, donc voilà, nous sommes en train de voir aussi le fait d'intégrer le SIG 3D pour insérer le projet dans son environnement et faire bien sûr de l'analyse spatiale à côté. Et les éléments finis aussi, voilà, pour avoir un modèle dans ce sens afin d'enrichir voilà, davantage les applications. Et ce qui reste, qui est en frein ce genre d'application, c'est que les maîtres d'ouvrage, ils trouvent ça du luxe. Ben, il faut développer davantage ceci et démocratiser ce genre de projet pour qu'on puisse aller plus loin. Et je vous remercie pour votre attention.
Merci Noureddine. Tarmo, can you hear me?
Yes, hello?
Yes, hello, Tarmo.
Okay, thank you very much for a great presentation. Does anyone in the audience have questions now? There is one question. I will give the mic. Wait.
I think it was the slide 12. If you come back to the slide 12, number 12. I know. Yeah, here. What do you mean by no support for SHM sensors in civil engineering?
So I mean that here in FC sensor type enumeration, we have not an exhaustive list of sensors that we have in our system. We have like a sensor of temperature, a sensor in building, something in building, but in our case of our structure, we have a lot of sensors that not figure here. So their propriety, we can't export them in our model. So that is why we put this remark, and it is an open discussion that can we have with Building Smart International to see if in their last version it is integrated or not.
I think, Tarmo?
Yeah. You were talking French, even you speak very good English.
Tarmo, can I comment on the question regarding
Yes.
IFC 4.3?
Yes, please.
You cannot hear
Karin.
me. Yes, okay, thank you, Tarmo, yes. No, I'm really interested in all of these issues regarding the sensors and the lack of some of these concepts in the IFC 4.3. I think the infra room would be really interested in looking at, perhaps together with you and also the ongoing European CEDAR initiative that both Tarmo and I are involved in. I think this would be really interesting. So Tarmo, if you can collect the contact details, maybe we can discuss this further.
Okay.
Yeah, I will take your contact details. Any other questions?
The IFC health monitoring project in the infra room, okay?
Yes, I think IFC health monitoring process would be very interesting, especially in COVID times.
Yes.
Okay, thank you very much for your great presentations. Yeah. Okay, our next presentation is BIM in new main lines in Sweden, case the East Link project by Jitka Hotochkova from the Trafikverket, the Swedish Transport Administration. And this presentation is video presentation. So I put it here or you put it?
Hello, I'm going to be presenting for you today BIM in new main lines in Sweden. Hello, I'm going to be presenting for you today BIM in new main lines in Sweden. Ralte, who was part of the huge BIM effort, received my PhD title. And the last 10 years I've been working with the East Links project. Before I came to Sweden, I have received my PhD title. And the last 10 years I've been working within railway. I have been in the picture, these fields are mandatory and this last field is optional. The first two characters, which you see right here, describe the responsible designer, in this case E2, and this is in the SB11 language, overhead line designer. The following 6 characters right here, they describe element. Element is indicating the functional part and construction work or structure. The next 2 characters, they are presentation, and presentation can be, for example, 3D, 2D, centerline, or text. And the very last character describes status, and it defines if object is new, existing, temporary, or for demolition. Since there was no established working with models, we needed to establish even this project. Models delivers from designer to the project client. Designer presents the whole data delivery in some kind of meeting. Simple presentation of coordination model holds. Presentation of views and model products are presented. And finally, the review of the model per technical field is presented as well. I'm going to be talking about the cooperation within the new mainlines. The background to this works is that the existing requirements was very poor and inexplicit. This was of course opening for different interpretations and frustration at both sides, both at contractors and at consultants. So our goals with the BIM requirements for the Eastlink and the new mainlines was to make a complete set of BIM requirements which are easy to understand. It was also very important that the requirements are clear and that there is only one way to interpret them. All the requirements are gathered in one database. This leads to consistent BIM products deliveries, and this way the BIM designer can also give more support to the project's leaders. In this picture you see the common requirement BIM database in the new mainlines projects. When the requirement database is used within the whole new mainlines projects, possibilities to implementations just expand. You have updated requirements which are implicit. We could connect other content to the requirements in the database, such as support text, checklist. There's a possibility to connect with the object library, and of course automated procurement. And we have also created requirement working process. And in this animation we show implementation of the requirement, but just from different point of view. This time we show that if you use the same requirement database, it is possible to use it, for example, for the whole Swedish Transport Administration with just a small adjustments for the projects who need it. The database also helps the different projects that use it to have control over requirements changes both within the projects but also compare to main database. And you can also have project specific procurement depending on the contract. This also means that in the delivery stage, every project has a full control over implied BIM requirements, even if they have changed throughout the project's life cycle. My colleague Janne Perre was a project leader for the requirement database. And finally, in this last picture, I would like to show you why we did all this work with BIM and digitalization both in the Eastlink and the new main lines, and what is the main and ultimate goal. It is of course the challenge between delivery of the data from production to the different maintenance system. And I think that this is not only specific for the Swedish Transport Administration. I think a lot of other countries knows this problem. It is very important to work with coordinated information structure, as we already do now in the Eastlink project. But we are not, of course, done. It is even more important to continue working through the whole information life cycle and all the way to the different maintenance systems. Because when you have the coordinated structure, when you use the coding systems, then it's much more easier to deliver from this uniform surface for local projects where you have documentation, properties, graphics, and metadata to all these different systems and functions which you have at this other end where the maintenance operation system is.
Okay. Thank you, Jitka. And now I think Karin and Jitka should be there in the virtually. Can you hear me? Karin and Jitka?
Yes, yes, we can hear you.
And Jitka is here, yes.
Okay, that's great. Thank you for the presentation. It was very interesting. Now, do we have any questions from the public on site?
No.
No,
Rella is not delivering any questions today. But we do have questions prepared. Do you have anything in the room, Tarmo?
No, any questions in the room? Please go ahead, Karin.
Okay, Jitka, how has the industry taken the usage of BIM in the Eastlink? What have been your biggest concerns and burdens?
Well, as I said in the presentation, the biggest concerns were that the industry pretended that they are much further than they really are. The problem is if they can work on their own and if they can work after their own requirements, then it's quite easy and they have no problems. But once we set requirements from the Swedish administration in order to be able to use the data and deliver them to the maintenance or use them for the building, then we see directly problems because they're not used to working like this.
Yeah, of course, we both worked in the Swedish Transport Administration, so this is really some questions asking to myself, but one of the questions that is of great interest, I think, to more people is the possible handover of this information to asset management. You mentioned it briefly. Do you want to say anything about the development forward?
Well, that's once again, as we mentioned, or I mentioned in the presentation, you have to ground it on the requirements. So all the deliveries look alike. We have the same structure of the data, and then we can start to work on the maintenance side with it. How does the data deliveries look like? Do we need to do some adjustments to our systems? And how are we supposed to adjust our systems? It is very hard for maintenance to start to prepare for those deliveries if the deliveries are if they look differently every time somebody else delivers. So it's hard. It's really hard for maintenance to adjust to these changes if we don't have requirements which make the deliveries look alike.
Yeah, I think what I was after was what Anna Neidenström will present a little bit more tomorrow, the way that the maintenance department now in Swedish Transport Administration, they have started to look at our deliveries and what it means to them and how they can make their own processes more efficient with working in the same way as we are in the construction phase. But this is all for the future. It's only just started.
Yeah.
Tarmo, do you have any?
Is anybody has question? Here is one question in the public. Just a minute, I will get the mic for Roland.
Hello, it's Ronald speaking. I was curious about the data transfer between the project database and the maintenance systems. If you have already some solutions in mind or are using them, are you using, for instance, APIs, web services to transfer the data, or what are you using for that? And how are you validating the data which is required for the different systems based from the project data model and system?
Do you want to say something, Jitka, or should I?
I can say that for our part, we are too early in to be validating data for the maintenance. As I said, we are in the planning phase, and now we are starting to plan for the building phase. But you can, Karin, definitely fill in as you are working on projects which are much closer to the deliveries.
Yeah, we do have a few development projects together with the maintenance department that will be presented tomorrow in the S14 stream, starting at 11:30 tomorrow. It's the third presentation that will be held by Anna Neidenström. She will present the development that is ongoing, Ronald, and we are looking at linked data and that type of technology. We're testing it right now to hand over some bridges and some lighting systems in a road project. So we do have quite clear views on it, but of course it's all in the starting blocks at the moment.
And then we can also add, I don't know if it's specific for the Swedish Transport Administration, but we have come further with the road projects than with the railway projects, especially when thinking of deliveries.
Yeah, we do have a project that is delivered at the moment, but we have a very good dialogue now with between the different parts of Trafikverket, building, maintaining, and also managing the traffic, of course. So there is a lot of good dialogue going on already.
Yeah, that's a very positive development.
Yeah.
Okay, thank you very much, Karin and Jitka. Tack så mycket, Karin och Jitka.
Tack så mycket. Thank you very much.
Thank you. And then we go to the last presentation, which will be here. Yeah. The name is Full BIM Design of the new M3 Toulouse Metro Line, focus on South Aerial Sector, and Mr. Christophe Fanovong. Yeah. Sorry, my pronunciation.
Thank you for being here. Thank you for being here for the last session. Just a few minutes before a glass of wine. I'm Christophe Anouvong. I'm working for Arcadis, and I will present you today the new project of Toulouse Metro line, the third line, and we'll focus especially on the southeast sector, which I am the BIM manager. We'll begin with the general presentation of the project, and we will try to explain to you on which consists the project. And just after that, we'll present the different process that the different BIM process that we used in the process. And the first design phase, the first design development phase, the phase 1 and 2. We will talk about the last phase of about the construction document phase, where I couldn't show you a lot of images, but a lot of pictures, but I will try to explain to you what we done with it. The city of Toulouse, for the people who don't know what it is, which city it is. It's the capital, European capital of aeronautic and special industry. It's the fourth in France in terms of ranking of population. And a city that known a lot of attractivity, so a lot of people come to that city for now. And it has already a good transportation network. A good transportation network with 2 metro lines, with 2 tram lines, and an important bus network. But it had reached the limit with a lot of people who come in the city for now, and so it began to be essential to link the northwest part of the city and the southeast part of the city, northwest part of the city, where is the Airbus company work. So this is why is born the. This is from this necessity of having this necessity that has born the third line of third line of metro of Toulouse, which we could also call it M3 or TE. For Toulouse Aerospace Express. It's a 27 kilometers project long. It's composed of 21 stations and principally underground, and with 5 kilometers of bridges, especially in the southeast part, in which we will focus on, and also a little part on the northwest sector. Since April 2019, we work in different joint ventures, in different design team on the project. I will just see someone. On the northwest part, there is Artelia and BG for this part. On the center part, we worked with Sistra. Sistra is the main contractor for the center part, and we work also with 3 other architecture firms. We work on the southeast part, where Arcadis is the main contractor, with another company firm called Séquence, and another engineering firm called OTIS. And we work on a Connex project. CLB is a connection line B. We are the main contractor also on this part, and we worked with Sistra and also Sequence. We can. There is also another project we call LAE for Line Aéroport Express, which in Europe is the main contractor for that part, and it worked with Conseil d'Ingénierie, Gauthier Conquet Associés, and more other engineering company. For the southeast part, so our client is TCO, and as I said before, you could see that there are a lot of actors on this project. So on this part where we will focus and where Arcadis is the main contractor, it's a part that it's a sector that is 5.1 kilometers long, completely aerial, with 4 aerial stations and with one shared station with the Line B connection. The Line B connection is the project that is the project that connects the line B to the new metro station. As many projects, these projects has known a lot of different phases. Since June 2019, we began the first design development phase, and and we worked on the second design development phase from June 2020 to March 21, and especially on this phase, I will focus the presentation later. Since 2020, the rail system designer has been nominated, is Alstom, and he worked with us. They work with us on the last phase, on the last document construction phase. And the construction phase will normally begin at the end of 2022 to finish for the civil part in 2026 normally, and normally the service launching will be made in 2028. With a lot of different actors on the project, and with open bin norms that just began in the infrastructure, it was very important to make BIM collaboration at level 2, and it has to be well thinked since the beginning for not having problem later. So we have three main principles on the project: the organization, the communication, and interoperability. Concerning organization, with the new project in the digital transformation era, we need to have a new objective, and this is why we need to have some innovative processes. And the TCO collectivity and TCO engineering, our client, has made the implementation of BIM one of this priority on the project. And this is why they worked with, they are assist with the BIM supervisor since the beginning of the project. Since the tender phase, they made the book BIM specification that ask all the participants of the project to respect open BIM norms and IFC format for all the exchanges and for all the deliveries. And for having maintenance later on the project, and for the city to maintain the entire network in the city and to maintain the city with the IFC, it was very important to to be surrounded by this BIM supervision unit, which have some missions to have the coordination, the BIM coordination. They lead the general BIM coordination, and to uniformizing the different level of details and BIM deliveries between all the different actors, and to create the general BIM models, breakdown structures, authoring different updated BIM details on the specification book, and verifying the conformity to the BIM client specifications from all the deliveries. In our different sectors, we have also different missions, and we have also the different missions as Arcadis. Since we are BIM manager on the project, we have to uniformize the different BIM deliveries into the groupment. We write we author the BIM execution plan. We have to identify the different contributors BIM, etc. And we have to organize the different BIM reviews that we have on the project, and to verify also all the different advancement on the project, and to verify the global coherence between all the different deliveries that we have. I think you are all okay with me to say that a BIM collaboration project like this, we need to have a good common data environment interface, and we can't do without it. So to have a permanent control of the different exchange from our side, from our design team, and from the client part, we use different common data environment. We use, for example, a Prozis Mezzo team. We use also Autodesk BIM 360, and we also use Bentley ProjectWise on the project, on the center part of the project. Concerning the CD that worked on the southeast section, Arcadis has decided to organize all his production to different all his production to Autodesk BIM 360 platform. About this exchange of to manage all the different exchange between the models, between FC models and Revit models, with the architecture firm Sequence, and with the other engineering firm OTIS. The coordination work and the different compilation that we have on the model has completely realized in the cloud, without never on our private server, and that was very useful during the lockdown and during the different smart working session that we had the last times. So we had a better workflow, and we have a better validation processes on the different level. The interoperability that given by the IFC format has helped us to face many challenges that we had to uniformize and to coordinate the production within different teams, three on the project scale. Three or four different architecture firms, 5 engineering firms, and we have less in our field, in our section, and we work on with very mixed environment in BIM, because different software has been used during the project, and with all the different actors. Depending of the different type of asset that we have to model, we use Autodesk Revit, Sophistic Bridge Modeler, and we also use ArchiCAD, Civil 3D, and GeoMedia Covadis. This is not on the schematic view, but we also use Bentley OpenRail for the more recent phase. And everything, all the different software that we use, it was very important to respect all the client demands on the project, especially on OpenBeam. So especially on OpenBeam and on the different structuration of the project, because the project is cut in different asset, sector, and different disciplines that we have on the project. Also, we have a lot of different attributes and different parameters that the client asks us to put on every element of every model that we have. We talk about more like 20 parameters that we have to put on the project. We use the software, the Sophistic Bridge Modeler software, which is a plugin on Revit to model the different bridges that we have on the project. We have already made a lot of beam project with bridges before in Arcadis, but it takes a lot of time before using this software. So we have to find something more dynamic on a project, and this is why we found Sophistic Bridge Modeler, because we already use Revit as a software for modeling all the different projects that we already have, and Sophistic Bridge Modeler as a plugin use Revit, use all the main components of Revit for 2D plans, for example, or also for the database management. So this is why we have succeeded to implement all the different information that we want on the project. And this has permitted us to have something more dynamic. We could have an alignment on the project. This is not a fixed geometry. So with the alignment, we can have different elements attached to this alignment, and so this alignment could be updated, and all the different elements could be updated with the alignment. So we created a lot of different parametric families before, and it takes just a little time before beginning the project, but after that it gives us we won a lot of time with that software. Also, we have very precise implementation of the different piles and different pile station, and we could make some bridges with double curbs, which is very difficult to model without a special software like that. And we could also generate real longitudinal section, which is quasi impossible in Revit without it. But it's not something magical. The bridge modeler will not model everything for us. We need some experience. We need to know the state of art on how to make bridges before using the software, and we have to set up every element to have something usable and something quickly updated, that we could update it very, very quickly. If we talk about updating, it could take up to 1 hour to update just one model if you update something in the alignment, for example. So we have to manage everything before to have something very efficient before that. So the challenge for the next phase, for the actual phase, for now, for the document construction phase, is to raise the level of detail and to output with the precisions the different material distribution on some particular bridge on the project. We also have more 2D plans that come from directly come from the models, because for now, for all the detailed element that we have on the model, we have to use traditional CAD software to put more details on some plans. And also we want to make, and we have made some pre-stress simulations on the project. Another challenge is to model all the environment for the bridges, all the environment, because all the projects is aerial, which is very difficult to make it manually, because we have the chance to have a lot of quantity of data before the project, and this data was mainly in GIS. We have different type of GIS data. We have point cloud. We have ASCII data. We have orthophoto in ECW. We have different building. We have different building in geodatabase. We have also all the water zone and all the different existing network on the project. So after different experimentation, we have found just a workflow, and we use InfraWorks to compile the different elements of topography, orthophoto, different buildings, all the different water zone and vegetation, and all the environment in our production software in Revit, so we could have all this by InfraWorks. For the environment in IFC format, they are generated by the topography and the orthophoto that we put in Civil 3D there, and export that to IFC, and so to export that to the client delivery. And everything with all the different attributes that we have on the project. As I said at the beginning of the presentation, we are now in the construction document phase. I can't show you a lot of different picture of that, but we have a lot of different feedbacks from the present phases. We have increased the level of details. We have reinforced all the different technical coordination, and we found a better way to have collaboration. Concerning the level of details, we not only increased the graphical detail, but we also increased the information that we put in the model, which is, I think, one of the most important things that we have done. We use unit class 2, and we use a work in progress unit class for bridges to implement all that in the project. For the BIM and GIS interaction, for that phase, we didn't increase a lot of the process, but we would like to have more thing on it. So with the different phases and with the different feedbacks that we have from the precedent phase, we have a sort of wish list for IFC, where the IFC could bring us further in the projects. We had the chance, as I said before, to have a platform with a lot of GIS data on it, which is called the maquette de l'état existant du territoire, which that we would use directly and automatically the data from this platform to our production software, and vice versa. We want to invert the different things. For example, all the different IFC models that we have, we want to put directly in the GIS platform, which is based on ArcGIS Online, but it was not possible at this moment. For all, for example, to validate all the different deliveries that we have on the project. So we could still see some incompatibilities between IFC and GIS, but we know that a lot of different actors worked on it. And I think it could bring the project in a further place. Concerning the IFC format itself, we have used the version 2x3. Why 2x3? It's an old version because of the compatibility between the different software. We wanted to use the IFC 4.0 at the minimum, as asked at the beginning of the project, but we noticed that some software like ArchiCAD or Civil 3D, the import-export engine, the IFC engine inside this software, are not very satisfying for all the different exchanges that we have. We wanted to have better geometries on it, and I want to avoid some triangulations on the different elements of the projects. Also, I think for everybody, we want to have some real IFC class for infrastructure elements like bridges, geotechnics, alignment, rail, etc. But it is not possible again unless with the 2x3 format. So we wait for 4.3 we want to have it soon as possible. We also see some classifications problems with the Uniclass for bridges, for example, because the client wants us to structure everything in the model with Uniclass, and for using it for the maintenance phase and for maybe his future digital twin. But for now, it's still difficult because everything is in working in progress. And for example, we found we can't match the different IFC class with any format, and to have so we have made some compromise on the project. We noticed also that Uniclass 2 and Uniclass for bridges share the same codes on the project. So for example, an elements in the building have the same code in the bridges, which can make some difficulties to have a good structuration of the project, because we have also some buildings like station, like upper ground station, and so they share the same classification. So it's still difficult. use it. Thank you for following this presentation, and don't hesitate to ask me more questions. I will be today and tomorrow here.
Okay, thank you very much.
Thank you.
We have time for one question. Is there any questions from the audience here? If not, Karin, can you help us?
Yes, I was wondering a little bit regarding the next phase. So for handover, you mentioned that you have requirements for handing over IFC. You say the client had a wish to work with BIM models, although I hear a lot of drawing production not being made from models, which is, of course, sad. But what does the next phase look like? Is it
on the models?
Is it going to be yes, for handing over?
The importation on some productions software is not possible with the IFC 4.0, for example. We don't see the geometries. So it's quite difficult to have some special coordination on the project with missing elements. So we noticed yes, some problem with the geometry principally. Even if the software is certified by Buildingspart, but yeah, so we notice some problem with some IFC engines. Yeah. For example, in our ArchiCAD or Revit, we have some problem with that.
Yeah, I think we are all longing for IFC 4.3 to come out into the market, and I hope the software vendors are listening to this and implementing as quickly as they possibly can. But what's the client's view on using models actively in the maintenance phase? I think that was my main question.
Okay. He wants. He have a different detail. He wants to use the different software You want to use the Uniclass format principally. It's in work in progress for the client. So the client asks us to do something, but he think about what he will do with all the information that we will have. So it's some work in progress in the two in both sides. So okay. we don't know exactly what the client wants with all the informations, but he will not have informations with on the models.
Well, thank you.
Welcome.
Thank you very much for presentation. Let's give a big hand for all the presentations this afternoon. Thank you. Yes. And thank you, Karin, for co-chairing me.
Tarmo, I miss you.
I miss you too. Okay, thank you everybody. Now it's time to have a glass of wine downstairs there. So thank you very much, and let's continue tomorrow. Bye-bye.
Bye-bye.
Bye-bye, Karin.